Hello again. This is our second worksheet on using the CF worksheet to calculate things about cash flows. And in particular, we're going to calculate the IRR, which stands for the internal rate of return. So let's get into that. Okay, so IRR stands for internal rate of return. It's also called the yield rate of a cash flow. And if you enter in a sequence of cash flows into the CF worksheet, as in our previous video, they correspond to a formula where A is the initial outlay, and then C1 is the cash flow at time 1, C2 cash flow at time 2, and so on up to Cn. And the net present value of all that cash would be this polynomial, A plus C1 times V plus C1 times C2 times V squared, and so on up to Cn times V to the n. And the equation where you set that equal to 0 is the equation that you solve for the yield rate of that cash flow. So if there is a solution, if there's one solution, that will tell you the interest rate, I, per period, at which that equation is true, and V is equal to 1 over 1 plus I. So that's what we're looking for, is how to solve for the interest rate I. And generally speaking, with complicated polynomial equations, there is no simple way, no simple analytic way to solve for I. Yes, if they're quadratic, you can use the quadratic formula, but most cash flows have far more terms than that. And so there's a lot of complicated polynomial algebra involved. But if there is one solution that seems likely, the CF worksheet will find it. Okay. So let's start out with an example. And we're saying that in return for a payment of $3,000 today, we will receive the following payments: $1,000 in 2 years, $2,000 in 3 years, and $1,000 in 4 years. And the problem is, what is our yield rate for that cash flow? And we have to enter that in there. So the thing is that $3,000 is our investment today. So if I go to the cash flow worksheet and turn on the calculator, cash flow, I hit the CF button, and I'm going to put CFO equal to negative 3,000. That's our investment today. You have to hit enter. Okay. Now there's nothing coming in 1 year. You still have to enter that to make sure that you have regular time intervals. So we're going to hit enter 0 on C1. And then the first cash flow comes in 2 years. That's 1,000. We enter that, and next cash flow comes after. It's only one time, so we go to C3, and that is 2,000. Enter, and the last cash flow is 1,000, and that is at C4. Enter, and so that's our cash flow in there. And if we want to figure out the yield rate at which the net present value, we talked about the net present value button, how you can figure that out at a given interest. But now we want net present value equal to 0 and find I. And for that, they have the IRR button. All right, so we're going to click IRR, and the first thing that comes up is what's the yield? And all you have to do is say compute. And there it is, 10.15%. And that's our answer. So at annual effective interest 10.15%, the cash flows that we described have net present value of 0. So that means that at that interest rate, the future cash receipts are worth the purchase price that I paid, the $3,000 that I paid today. So that's the how that works, and it's pretty convenient for finding a yield rate. No solving polynomial equations or anything. Okay. Let's go on to the next one. Okay, we did talk about a project evaluation problem last time, so let's talk about that. And so project 1 requires investments of 10,000 at t equals 0 and 5,000 at t equals 1. And it is predicted to return 2,000 at t equals 3 and 6,000 at t equals 4, 5, 6. We talked about this problem in the previous unit on cash flow. And project 2 requires an investment of $6,000 at t equals 0. And this time we're going to say the return is $3,500 at t equals 1 and $5,000 at t equals 4. So that's a specified time at which the $5,000 is paid. And now the problem is, what is the yield rate, I, at which both projects have the same net present value? So that's the idea, is what interest rate are those projects worth the same in terms of present value? And so the present value of the first project is minus 10,000, that's the initial investment, minus 5,000, another 5,000 at time 1, and then 2,000 at time 3, 6,000 at time 4, 5, and 6. So using the discount factors, that's what it turns out to be. And on the other hand, project 2 is 6,000 investment, negative 6,000, and then you get 3,500 at time 1, so times V, and 5,000 at time 4, and that's times V to the 4th. And they should be equal. Now we're looking for the yield rate under which these two projects have equal present value. Okay, so we're going to simplify that expression, move everything to one side, and make it look like a present value equal to 0 calculation. So we're going to add 6,000, and then you get negative 4,000, minus 10,000 plus 6,000, negative 4,000. Subtract 3,500 from minus 5,000, you get negative 8,500. Subtract 5,000 from the 6,000, and you get 1,000 times V to the 4th. So this is our new present value equation, and that should be equal to 0 for the internal rate of return. So we're going to enter that in cash flow. So you'll have to clear it first. And the initial outlay, we just read off the coefficients here. So this is 4,000 minus, enter. Next one is 8,500 minus, enter. Okay, there's no V squared term, so we have to put in C2 equal to 0. And then we have to keep going, and C3 is 2,000. Enter that. And C4 is 1,000. Enter that. And C5 is 6,000. Now this is repeated at time 6 as well. So we can enter that and then say F5 is 2 to repeat it. So let's write down what those buttons were. Here they all are. And now we have the cash flow in there, and the rest of it's really the same as before. We go to the IRR button, and then you just hit compute. And there it is, 4.2602%. That was pretty easy. It was almost instantaneous, whereas trying to solve it by numerical methods would take a while. So that's how we get the IRR, and it's a very powerful worksheet. It can do many different cash flows, and I hope it helps you. Okay, so we'll see you next time.